Hi everyone, today we are going to be talking about distance, rate, and time problems. Go ahead and grab a piece of paper and a pencil and let's get started. Question number 1. Two trains leave the station at the same time, traveling in opposite directions. One travels at 70 miles per hour and the other at 60 miles per hour. How long does it take for the distance between them to reach 390 miles? Okay, let's go ahead and define our variables, and then we're going to fill in our chart with all of the information that we know. Okay, let's go ahead. So again, we're going to let t represent the time for the trains to separate 390 miles. Let's fill in our information on the chart. So up at the top, you'll notice we have distance, rate, and time. So for the rate for train 1, we know it's traveling at 60 miles per hour. So under rate, I'm going to write 60. The second train travels at a rate of 70 miles per hour, so I'm going to write 70 in the column underneath rate beside the next train. We know the total distance between them is 390 miles, so I'm going to add that in the column under distance. And the time is what we're not sure about, so I'm going to put a T under the time column for both of them. Next, we're going to look at multiplying the rate times time because distance is equal to rate times time. So 60t is under the distance and 70t for train 2 under the distance. If you don't like the way the table is organized, you could have put rate and time first and distance in the last column. It doesn't really matter the order. So if you prefer, you could say rate times time equals distance and then have 60 and 70 in the first column, and then the t's under the time, and then under the distance, 60t, 70t, and 390t. But again, it really doesn't matter the order of the table. That's just how I wrote it for this particular example. Okay, next we're going to go ahead and come up with our two equations. Okay, so we're going to get our equation from the distance column. So 60t plus 70t is equal to 390. So let's write that down and then we're going to solve for t. Okay, so 60t plus 70t is 130t. So 130t is equal to 390. Next we're going to divide both sides by 130. So 390 divided by 130 is equal to 3. So therefore it will take 3 hours for the distance between the two trains to be 390 miles. Okay, let's look at our example number 2. A train traveling non-stop to its destination is able to make the trip at an average speed of 72 miles per hour. On the return trip, the train makes several stops and is only able to average 48 miles per hour. If the return trip takes 2 hours longer than the initial trip, what is the travel time in each direction? Okay, let's go ahead and define our two variables, and then we're going to fill in our chart. Okay, so we're going to let t represent the time to the destination and t plus 2 represent the time to return. Okay, so let's go ahead and fill in our chart. So going to the destination, we travel 72 miles per hour, so that's our rate. We don't know how long it's going to take, so that's t. On the way back, the average is 48 miles per hour. And that took 2 hours longer, so t plus 2. So for our distance, we're going to multiply the rate times the time. So 72t is to the destination. And we need to make sure we remember to use the distributive property, so 48 times t plus 2. So 48t plus 72. Okay, so we're going to use the distance column to help us come up with our equation. Okay, so using that first column, our equation is 72t is equal to 48 times t plus 2. We're going to use the distributive property here. So 72t is equal to 48t plus 96. Okay, let's go ahead and solve for t. So 24t is equal to 96, dividing both sides by 24. So t is equal to 4. So last but not least, we're going to sub t is equal to 4 into the equation. So next we're going to substitute t is equal to 4 into t plus 2. So 4 plus 2 is the return time. So the return time is 6 hours. Okay, so let's go ahead and make our conclusion. Therefore, the travel time to the destination is 4 hours and the return time is 6 hours. That's all for today. Thanks for your attention. Bye-bye.